stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? I'll tell you what we have on the menu later, but first, Happy New Year. And I see some people here on the chat, so let me say hello to Mage and Nod was one. Thanks for joining me today. You can tell that this is not my usual stream setup. Happy New Year, this is what we have. The truth is that next month, I won't be here in this space. I will not have access to my usual setup, my lights, these lights, my camera, my microphones, none of that. I'm not taking any of that with me. But I am taking a laptop, and I always wondered, because you know how it goes with me, right? It happens in code as well. I start with an idea and then it gets complicated, and then I find some kind of unifying solution and then it gets a bit simpler again. In fact, it is going to happen today to the code that we are going to write. We are going to be simplifying some things in the data bender. But I guess the same happens with setup for me. I start with something simple. I only had a laptop a couple years ago, and then I improved on the camera, I improved on the microphone several times, I improved on the lights. Now I want to experiment. What does it look like, and how does it sound like, and what is the experience of the stream like if the only thing I have is the laptop? I could even wire it to the internet, but I am using the Wi-Fi, just because I want to see how well all of this can handle over Wi-Fi with only one laptop. How much can I do in this exercise, in this exercise of minimalism, especially on the upcoming month when I will not have access to all of this. I will have Wi-Fi and I will have a laptop, and that will be it. Can I still stream? Can I still create content? I sure hope I do. I hope that the stream is sounding okay, that you can understand me, and that the internet is good enough. And if it isn't, I will probably have to decrease the quality, but probably it will still okay. It looks like I'm using my 2016 phone for video. True, yeah, I am using a MacBook with the M1 processor. It's a MacBook Air, the first one that Apple released. And the quality of the camera is not good. The quality of the camera is not good. But the quality of the microphone is pretty acceptable in my tests. So I don't look awesome, but I sound reasonably okay. And Apple does a great job at reducing noise and leveling and equalization. In fact, I don't have any processing going on besides what is built into macOS. And I think that this is listenable. In fact, I tend to worry too much about these technical details, but then I look back on the kinds of videos that I watch, and sometimes they have been recorded with a phone camera, maybe even a computer camera like this, which is even worse than a phone camera. And depending on how things go, I may use my phone, which has a better camera, and you can connect the phone to the MacBook and use that as your camera. But not today. Today we are going to exercise extreme minimalism, I guess. Anyway, what we have on the menu today is the data bender. We are going to continue exploring the data bender. And there are three things that I want to do with the data bender today. The first is I extracted some auxiliary functions that I used in the data bender as well as in other projects into a package. I did this afternoon. So this is a new package, and we are going to be using one utility function from there in data bender. Pretty straightforward thing, but it needs to be done. The second thing we are going to do is, again, the process of simplifying, starting with something simple, complicating things, then getting back to a simplified concept. We are going to find the common parts of the code that we wrote, and we are going to extract a function that does one data bench. And extracting a function is probably the most straightforward abstraction you can introduce in a code base. But I think it will be useful for reasons that will become apparent when we look at the code. And then we are going to wrap up by exploring even more formats. It has been what we have been doing in this project a couple sessions, for a couple sessions at this point. We explored different filters, we explored different pixel formats, but we still have to explore different audio formats, and there are more things to look at. We are going to look at these things. Let's start with the introducing this library, which is pretty straightforward. And Dale is here. Hello! Great to have you here. I have a really old 32-bit laptop and the camera is bad beyond all reason. Yeah, cameras on laptops are not awesome. All right. Cameras on laptops are even worse than cameras on phones, which I guess makes sense. A phone these days is pretty much a camera that makes calls. Let's install this library. And this library is this grab bag of utility functions that I have used in several projects at this point. There is one case that we are interested in this case, in this project, and that is the part where we do this line. Here we are detecting whether this JavaScript file is being executed or if it is being imported. I plan on allowing people to use the data bender in at least two different ways. From the command line, or if you have a JavaScript program and you would like to incorporate data bending into that, we do export the function and you can use that from a programmatic API from JavaScript. So in here, I have to detect what is the case. Am I being executed or am I being imported? And I used to have this line copy and pasted in many projects. And this line is not trivial, it's not too complicated either, but it doesn't look good. It is kind of, what is this saying? Unless you know what it's saying, it's kind of hard to tell. So what I did is I extracted this into the library that I need to import now. And I usually have a kind of logic to where the imports go, and I think that this one belongs here. And now I hope that this reads better. You're asking the function, is this file being executed? If so, run these things. Otherwise, it's being imported, but we don't have to do anything special in that case. And with that, we should be able to run the data bender, and it should work just the same as before. And is running the same as before. Here is an example of a data bench that it produced. Pretty cool, actually. Here is the original. Not bad. So number one checked. Number two is more interesting. Let's look at the structure of the code that we have written so far. and then I will show you what I want to simplify. The data bender function, this function, started its life as just the body of the program. It receives some input file and it will do a data bend to that file a given number of times. But then we wanted to explore different pixel formats, different filters or audio effects. We wanted to explore them exhaustively. We wanted to see what all of them looked like. And then we end up with this kind of predicament where you have a for loop over a bunch of pixel formats. Here is a long list of pixel formats. So you have a for loop over that, and then you do this bit that starts here and ends there. I will put this to the side. I will leave it here, and we are going to continue scrolling here. Then you do the exhaustive exploration of all the audio filters. And then you have code that looks like this, and it is very similar, isn't it? Then we do the default case, which is to do 10 data bands with random parameters. So we are not doing, in this case, an exhaustive search of all the filters or pixel formats. We are randomizing and creating unique data bands. But still, kind of looks similar, doesn't it? Look at these lines. And then it's doing the selection of pixel format and audio filter and whatnot. But then here it picks up again and it kind of looks similar again. So that core is what I want to extract. And I want to, in this case here on the left, we have a try catch because this may fail depending on the audio filter that you try to apply. It may not work. So we have a try catch here. On the right, we don't have a try catch. I want to have a unifying concept. There will be a try catch in every case. Over here on the left, we are interested in the timing. So we check how long things took. And here on the right, we are not interested in that, but I'm going to time it anyway because it's not expensive to time something and it can be useful. Hey, Bo is here. Hello, Bo. It's great to see you all here. Fills my heart with joy. Thanks for joining me today. So we will have a data bender, or maybe... Here's the thing. I'm not sure if I want to expose this function or not. To begin with, I will not expose this function. It will be an implementation detail of the data bender. Yeah. Maybe later we will find some reason to extract this function out of this function body, the auxiliary function that I'm going to define, may be extracted out of this function body. But to begin with, I'm going to implement it here in this function body. And I am reasoning about this because you probably know me at this point. I am averse to premature abstractions. And a local function and a local auxiliary function is probably the cheapest abstraction because you do have access to all the variables that exist here, for instance, if you find that that's necessary. And it's also less stuff for us to maintain further down the line. If this becomes super successful and everyone is using the data bender, then the more functions we have that people can use, the more we have to maintain and think about backwards compatibility and whatnot. So a local function is what we are going to do. And I think that it makes sense for this local function to exist here at the bottom of the function definition. And I suppose it makes sense for this function to be above these other two auxiliary functions, because when you're reading the code, you're going to find all the meat of the implementation first, and then you're going to find all the auxiliary functions, and you're going to find them in order of importance. And I'm going to call this, I guess, data band. I could pick the same name as the function, the surrounding function. I could pick the name data bender, because so far there is no recursion going on. But I think calling it something else will be better. Yeah, and I already know that I will need a lot of parameters for this function. So I'm going to not use positional arguments. I'm going to use an object here, and I will use the structuring assignment instead. And I know that this is going to be a function that is, of course, asynchronous. So the return type says promise, but it's not going to return anything. Oh no, wait, it is going to return something. It's going to return the time and whether it succeeded. Yeah, I'm not going to use, I could use exceptions to indicate that the function failed. Yeah, so when you're writing a function, you have two ways at least two ways that I can think of right now to indicate that the function failed. The first is to return something with a failure flag somehow, and the second is to throw an exception. And the trade-off is, if you throw an exception, then everyone who calls your function potentially will be having to do a try-catch block. And if you return some kind of flag, then the callers may ignore the result, which could get you into trouble. But in this case, I think it is better. I think that having a lot of try-catch blocks is not really good. Doesn't fit my style. So we are going to have some kind of success flag. And this is complaining because I'm not returning anything, I think. So if I return success true, then it's happy. Okay. And we are also going to return the time, which is going to be a big int. That's how long the function took to run. Now it's complaining again. So let's find a place where we do the timing thing. First we get the time like this. And then at the end, we use the time like that. And the high resolution timer, this is what this stands for. It's the process high resolution time, big int, that is going to give you the time in microseconds. I think it's going to be in microseconds. So if you divide by 1,000,000, you get it in milliseconds. Or is it in nanoseconds? I forget. I just know that this equation here is going to give me the time in milliseconds, and that's what we need. You know what? This kind of arithmetic is not self-explanatory because I am trying to explain it, and I'm sort of failing because I don't remember the unit of measurement that this returns. It is probably in the documentation, but still. It includes fractions of a second, but it doesn't. Oh, this is the uptime function. Yeah, this doesn't even document what this is. What is the ARH time? See, I would have to go to the documentation for the process in Node.js, which is not too hard, but still, it's a step. When you're reading the code, you're like, what is this? What is the unit of measurement? So I find myself having to write this equation over and over too much. How about we take a detour and add it to that at liafac node library that I started this afternoon. So as you can see, this is a grab bag. There isn't really a rhyme or reason to what is in here. They're not exactly related, so I can just throw this anywhere. But I think it makes sense for me to throw this next to this function because it does have to do with timing. In fact, look, here is our equation again. So export function elapsed time given a start. That is going to be a big int. And I should say that this function is going to return a big int as well. And that. And now there are 3,000 places in all the projects I have where I have to use this. So I'll not do this right away with all projects. But I will. I'm thinking if I will publish a version of this so that I can use it in this other... No, I will do this later. I extracted the function. I will use it later. For the time being, let's just let this be here. This equation will appear here. Anyways. Now let's find the place where we have the common code. For instance, here. And we will start copying, pasting, and adapting. So here is something that we need from whoever is calling us. The caller needs to know what is the pixel format that we are interested in. But more importantly, I think that the caller needs to know what output it wants, because sometimes the output is the name of the pixel format. Sometimes the output is the name of the filter. And sometimes the output is the name of, it's the number of the data band. So this is not something that these things have in common. It's actually different. So I will receive the output, which is a string, as an argument. The logging, however, is common in all places. So I'll leave this here. Then next, we have this line. And this has a bunch of things. The input is an argument that we get for free because the input is actually available to us in the data bender function, and we are in the context of the data bender function. The data bend function is defined in the data bender function. So we get this argument for free. We don't need to pass that as an argument here. We could, maybe we should, but we're not going to right now. Then there is the size. Size is an argument that is also available to us for free, because the size is determined as part of the parsing of the metadata. It is here. And this variable is in scope there. So we don't have to do any extra work for this. See, that's why I wanted to have this as a local function. You have been having fun playing around with ChatGPT. Yeah. What have you been doing with it? Are you using it? I remember you mentioned in the Discord chat. And if you don't know about the Discord chat, you should go to the link in the description. Anyway, I remember Bo mentioning in the Discord chat that there is someone doing guitar pedals with ChatGPT. I didn't watch the video, but does it work well? What are you doing with ChatGPT? Are you using it for JS effects or something related to digital signal processing? And yeah, we have Anonymous, or I guess that's how you pronounce it, Anonymous. Hello from Portugal. Nice to see you here. Thanks for joining us. We get the size for free. The input metadata frame rate we also get for free. It is available here. The pixel format. The pixel format is not something we get for free. Yeah, there is a default pixel format here that we could use, but no, we want to give that as an option. And that's also a string. Ooh, there is something really cool about coloring. I'm not the hugest fan of syntax highlighting, but there is something really cool happening here. It is called semantic coloring or semantic highlighting. You can see that the shade of blue is different from the input, which is a function argument, to size, which is a constant that we have defined. Isn't that cool? This slight difference in shade means that the input, since it is a function argument, it is immutable. You could, if you needed, say input is equal to something else. It's probably not the best idea to do this all the time because it can be confusing. You would call the function with input one thing and then it's something else. So it can be confusing, but it is available to you and sometimes it's useful. But because we have defined the size as a constant, that is a darker shade of blue, and Visual Studio Code knows that. That's super interesting. And here the input metadata is a constant, but it is an object, and the fields in object are mutable, so it is in the lighter shade of blue. I have never noticed this before. Super cool. Then the pixel format, again, it is an argument, and the input raw, I have a feeling, yeah, that it is available to us as well. It's right here. And this input, despite its name, is actually the output of this invocation. Fun stuff. It's just that the input is a video file like an MP4, an input raw is that same file, but without any metadata, ready for us to data bend. And it happens to be the output of this first invocation of FmpEg, which is responsible for converting from whatever format into something we can do data bending with. Then we have this variable called succeeded. I think I will call it, I will rename this variable success in this block of code so that I can copy and paste things more easily, because this is exactly the logic that we'll need here. And perhaps we can even get rid of this line. And do all of this stuff. Now the try catch block is around these two last invocations because hopefully this first invocation will never fail. But the truth of the matter is that if you pass me an input file that is not a video file, probably FFmpeg is going to choke. So we might as well put this try catch block around the whole thing. Yeah, so the way that I wrote this function now is as soon as the function starts, you have the try block, and the whole body of the function is in the try block. So if you succeed, you will call ffmpeg 3 times, and we don't actually need a success variable in this case. Or we may do it like this. Yeah, I think that this reads nice. Thanks for the moderation, Tail. Being troubleshooting code and asking general code IDE related questions, plus some weird physics related thing. You just ask if a wild idea is feasible and it already does the math for you. It's awesome. Oh, great. Excellent. I haven't played around with these things myself, as I said in the past, so I'm always interested in knowing what people are coming up with and how good is it in answering these questions. Because I know that it knows a lot, but I wonder if everything that it knows is actually accurate. That is my main thing with these kinds of AIs. Sometimes it's harder to tell correct from incorrect information than to just seek the information by yourself in the first place. That's how I feel. That's how I felt with GitHub Copilot, for instance, but haven't played with ChatGPT yet. Okay, let's look at the structure of this. We have a success variable and a time, and this time is going to include not only the time of the filter, but also the time of the conversion from and back the original video format. But I think that that's fair. And yeah, all of this looks good. And then in the body of the try block, what I expect to see as the last line is it saying that success is true because it got to the end of the try block. And see, the ffmpeg function may throw, and it doesn't even throw explicitly. Well, I guess it does, because it wants to log the command. Yeah, it's only throwing explicitly because it's logging the result of the command. But in Spirit, what is throwing the exception is exec A, which is just invoking ffmpeg. But here in this other function, we are converting from an exception into a flag. I mentioned that there are at least two ways of representing error in a function execution, a flag and exceptions. We are going from exception to flag. And for some reason, I think that this makes sense in this context. Anyway, so the body of the try block is logging something. It is invoking ffmpeg 3 times, and then saying that that was a success. So the first is converting from MP4 into RAW. The second is applying an audio effect to a video file. And the third is converting back from RAW into an MP4, for instance. So now the only thing we have left to do is to go over all these parameters. We already did that for this invocation, but there are still two invocations that we need to go over and find all the parameters that we need to declare as function parameters. So the pixel format, we know that we want as an argument. The audio format, the audio sample rate, the audio channel count, the input. Oh, hang on. There is something else to consider here. Not in the case that we were using as reference, because in that case, we were exhaustively exploring all the possible audio filters, for instance. So not in that case, but in the case where we are doing random data bands, the actual use of this project in the end of the day, we have this to do here, and that's something that I want to incorporate into this function. It's one of the reasons why I'm defining this function. And that is, what happens if you take the input, convert that into a pixel format that may be like, let's say RGB24, you do the data band, and on the way out, you could just pass RGB24. So the only data band we did was to apply an audio effect to a video file. Great. But what happens if on the way in, you say that you want a pixel format of RGB24, and on the way out, you want YUV 420p? What's going to happen in that case is that it's going to interpret the bits the wrong way on purpose. And that may be interesting, that may look cool. So I don't want to simply have a pixel format. I want to already address this to-do and have different pixel formats for input and output. But I want the output to default to the input so it is easier to use. So I guess we are going to have something like input pixel format, or maybe let's have something like this: output pixel format, which defaults to pixel format. Just like that. So on the way in, we are going to use pixel format, and on the way out, we are going to use output pixel format. Yeah. And if you don't want to specify that, you will do the regular thing where you match pixel formats on the way in and out. For the audio format, we just want that as a parameter. There is nothing special in terms of inputs and outputs there. Another tangent. You can see that I'm declaring all of these guys as strings. I am in TypeScript, so I could be declaring this as elements from this list, because those are the allowed audio filters. Is there a value to doing it this way? Is there a value to be more strict with the types? At this point, I don't think so, but I wanted to bring this up because it is a consideration. You could, instead of having this, you could have something like, let's not do this with audio format, let's do this with pixel format that I was talking about. RGB24 is a pixel format, or YUV420p is another pixel format, and then the caller of the function would need to provide one of these values, not just any string. And when using when using type systems, as well as when using any kind of linter, static analysis, all of these things, you have to consider what is the cost of enforcing things. Not necessarily from a performance perspective, because the type checker is going to be faster, but from a maintenance perspective, what is the value that this is going to bring? Not too much, I don't think. Especially this early on in the project, so that's why I'm declaring this as string. And that's another thing I love about TypeScript. If I wasn't even sure that this was a string, I could just say any. I love this. I can opt out of the type system, and TypeScript is gonna say, okay, you do your thing. I will do my best. And if the program fails at runtime, it's your stupid fault. And I love that attitude. Audio sample rate, same story as audio format. Channel count. We could be cute and pass this as a number, because it is a number, but whatever. Then input raw is available from the context. Audio filter is a parameter. Oh, this is another place where we could have an audio format on the way in and another audio format on the way out. So you would interpret the bits that make up a video as if they were audio encoded using MuLaw, but on the way out, you interpret those same bytes as if they were audio encoded using 32-bit PCM, for instance. Linear PCM in that case. Yeah, let's do that. So we are going to have an audio format and an output audio format that is going to default to the audio format. And we are going to use that here. And I am feeling like the sample rate and the channel count could receive the same treatment. Let's do that. And then output raw is the same as input raw. It is available in the context. Then for the size could have the same treatment. It happens, we already tried this in previous streams, something really cool happens if you provide sizes that don't match. The video starts scrolling up, it's crazy, so we want that. But the input size is given to us from the context. So do we want to use the size from the context? The size that we see in the context is the real size. And I suppose that you want to use the real size when converting this. Well, I am sure that in this place right here, this is where we are converting from RAW back into MP4, for instance. So in this case, we definitely want to use size, no question about it. But here we could use something else, and here we could use something else as well. So I guess I'm going to give this a weird name that doesn't match the rest, like input size. And the reason why I'm doing this with this weird name that doesn't match the rest is that I still want to have this size available from the context at this position. So I cannot call that parameter size, which is kind of unfortunate. But anyway, so we have the input size, and now we have the output size. And by default, if you don't provide an input size, you default to size. And if you don't provide an output size, you default to the input size, like that. Or maybe we could rename this variable instead. Yeah, input metadata size, how about that? Or even, how about this? Because it is part of the input metadata, it's just a constructed field. Why do you not like this? Oh, because I have the wrong variable name. Now that's better. So the last part of this refactoring is this. Did you see that? I went into refactoring by pressing F2, and usually you give a name, but in this case I didn't give a name, I gave an expression. And this is not even valid JavaScript, you cannot do this. But whatever, Visual Studio Code will do it, and it will be smart enough to not only rename this, but also all the variable occurrences related to this variable. So now this is no longer valid JavaScript, but whatever, we are getting rid of it. But the cool thing is that the rest of the code where it was using size, now it is using input metadata.size. Cool stuff, huh? It's a little refactoring trick that I picked up. And now that we are using input metadata size, we can rename this to just size, which is more sensible. I like this better. Awesome. It's pretty accurate. Oh, great. The more specific questions you can ask, the better. I asked it to make a Lua script for Reaper and the script didn't run. Pretty sure it's fixable, but I moved on to other things. What is the degree of the issue? Was it a valid Lua program, or was ChatGPT not even getting the syntax right? Because those are different levels of getting something right. You can write a Lua program that is valid Lua, but is misusing the Reaper API, and I would accept that error more easily because the Reaper API is very specific and you get it. But if it's getting the syntax of Lua wrong, that's kind of a deal breaker, because that's a lower level mistake. You could also argue that it's an easier mistake to fix by hand. If you know a little bit of Lua, you're going to see, oh, it's missing a keyword here. Bam. If the logic of the program is right and the use of the API is right. Anyway, but good that you are making progress and playing around with these cool things. I don't want to get addicted to playing with AI until we see how much the subscriptions are going to be. Free betas are a trap for the unwary. Oh no, I've become like my dad, a killjoy. Yeah, there is the cost. I also feel, I don't know how I feel about all this. It's definitely interesting, that is for sure. The error said something about gsub. That's a function to do global substitution in strings in Lua. So if the error said something about gsub, it's probably because gsub appears in the code, which is valid Lua. So I guess good on ChatGPT for getting Lua correctly. Perhaps there was some logic problem in which it was trying to use gsub with something that wasn't a string. Something like that could happen. Type errors, again, because Lua is not statically typed. Oh no, input metadata frame rate is complaining. Why is it complaining? Oh, it doesn't pick up the type from the dot groups thing. Oh no. Yeah, we have 1,000 errors here now. Why are you doing this to me? See, the type? I was just saying how TypeScript is great. And now the type of this thing is nonsensical. It's saying that the type is just size because I declared size explicitly, but I also have the groups variable here, and it should know what is in groups. Oh, it doesn't. So I see two ways out of this. I could have some kind of generic here No, it's just an array of string. So I don't have a way of specifying, because in some functions you can come here and do a generic and specify what you expect the groups to be. Unavailable to us. Next, we could specify these types here, maybe, or even there. Or we can do the thing I mentioned before, as any. Fuck this thing. All the errors are gone. And that's the shotgun. What else? Are we missing anything? I don't think we are. I think we nailed this. Everything that needed to be a parameter is a parameter. Every parameter that needed a default value has a default value. I'm happy to see the changes and commit this and try to use it. Let's see what we changed. So we did this shenanigans with the input metadata. And to be honest, this as any is not really anything worse than we already had, because the type of the input metadata before was the type of groups, which is essentially any. Maybe we could be ever so slightly fancier and do it like this. At least we are saying that the thing is an object. Yeah, let's do that. I always feel like when I use as any, I am cheating and I should be using something else. So now at least we are saying that it's an object, but we are not being specific about keys and values. And I suppose at this point we could be explicit about all the fields. I will have to do it now that I said it. There you go. Are you happy now? No errors and no any's. Whatever, we are just creating more work for ourselves in the future when we do something smarter with the input metadata. If you change the regular expression here, you will have to change the type there as well. And in some ways we're making it worse by being more specific, because now if you change here and forget to change there, then the code below is not going to work at runtime, but it will compile, and you will have a false confidence that this is right. Yeah, whatever. Yeah, for the most part, we renamed some variables and we created this function. So overall, we are making the code longer and more complicated. We are doing the expansion bit. Now let's bring it all together again and start using that function. So the output is still something that we need to do, and then we can just call the function with the given output. Many of these parameters, except for the pixel format. Well, actually also the pixel format. It doesn't really come from here, it comes from there, but whatever. Just like that. And you are still missing arguments, aren't you? Output, pixel format, audio sample rate, audio channel count, audio filter. Yeah, we're not missing any arguments because all the other arguments that I did not specify have a default. The problem is in the type, I am requiring you to pass an argument even though a default exists. So when you have a default to an argument like that, on the type you should put a question mark to say this is optional. And then that is optional. And then this, and the other one, and the last two. And now it's happy again. And this replaces all of that. Our code is getting simpler again. And in this case, we are not using the output in multiple places. We are just passing it as an argument here. So I am going to inline that there. And then that whole block is now just one function call like that. Great. And I'll call this the result of the data band. That's all there is to this. Amazing, huh? The next one is going to look very similar. I'm going to fold the list of audio filters, and I am going to copy and paste at least this part. And then we will be able to delete a block of code as well. Awesome. And then third, this is going to be a cool one. The output can come from here. We are addressing this to do ever so slowly because it's a lot, but we are addressing it. Pixel format. I can just grab this whole thing and boop, put it there. Fold. Audio format. There. Sample rate. And with that, we can get rid of all of this. I think. Nope. That broke the code. Prettier is telling me that that's a syntax problem. Let's do one at a time. And use different inputs and outputs. We still have to do that here when invoking this function. The function is perfectly capable of doing it. We have to call it like that. So I'll leave the to do there. And here is a little trick. We are not doing anything with the result. But remember, we have a flag to indicate if the band worked or not. And we could just not check it, but I think I will check it. And I will throw an exception in this case, I guess. I'm going to go back from flag into an exception. Whatever. And the message is going to be failed to data band. Check the logs for more information. There you go. I'm going to cluster all the to-dos together. And this is the kind of commit that we all live for. We have more deletions than additions, and we have more deletions than we had additions in the previous commit in which we extracted the function. This is what we live for. Let's quickly scan. And it looks good to me. Let's see if the thing still works. We got a data band. We have to do something about the bitrate. Speaking of bitrate, let me know, how is this stream going? How do you tolerate? I'm not gonna say appreciate. How do you appreciate? Because you cannot really appreciate this kind of production value compared to what I used to do. I think that what I used to do is much better than this. But how do you appreciate the spontaneity? I don't know how to say this word. And how do you tolerate this setup? Do you think that I can continue streaming in the other place, or should I do regular videos instead of trying to stream? It seems to be acceptable. No one is yelling in the chat. Perhaps we should have fun while we may. Once civilization falls from the outside context problem caused by the arrival of alien ships, it will be too late. John Matthews is here. Hello. What is up? Alien spaceships sound fun though. Yeah, we are doing more data bands, and we are actually bringing structure to the program so that data banding becomes a little bit easier. Brave, deleting code like this without double and triple checking, I would break everything if I did so. Yeah, I kind of checked in several ways, to be fair. I checked with Prettier, which is something that I always am running, and you don't see the keyboard shortcuts appear anymore because I am doing the laptop thing. But yeah, I'm always running Prettier to check that I don't have any syntax errors. I also scanned the git commit. And worst case scenario, I can reverse, but I never do. I never reverse. If I find an issue, I always look at the old commit and I adapt things, because there is always something else going on in the code base. No commit is clear cut. I think that maybe if you have a big project and well-structured pull requests and they last weeks in development or months in development, and everyone does a good code review with a team of people in a room, maybe you have a self-contained commit that you could reverse. But in these kinds of projects, relatively small to medium-sized projects that I work on, I don't find the Git history super useful for this kind of thing. It's too useful just for other things, like sometimes before I do a release, I look at the differences between what I'm about to release and the previous version that I have released. This Git tree compare plugin is great for that. So that comes in handy. I guess it does usually look better, but in my opinion, Stream is fine this way. Thanks! Awesome! It means that I can continue doing what I like to do, even if I am not in the place where I usually do it. And when I come back here in 1 month and some days, I will go back to the other setup with a better microphone, the better lighting and everything. But it is great that this is working. Perfect is unachievable, but done is better than perfect. All right, we said that we would restructure this and we did. Now let's explore more formats. I find this super exciting. We have been doing this for several streams and it never gets old for me. So we explored all the filter formats, or sorry, the pixel formats, and we explored all the audio filters. The next thing that we can explore is maybe audio formats. Yeah, let's do that. And in case you are wondering, audio format means how do you take a sample and represent that with bits. You measure a sample, you do the analog to digital conversion. Now you have to pick a system to represent different levels of amplitude with bits. How do you do that? There are different ways of doing it depending on the kinds of how many bits do you have and how do you want to use these bits. Those are all different audio formats. Lovely, that's all I need to do. Now let's see what are all the audio formats supported by the specific version of FFmpeg that we are going to use for distribution. So I'm gonna go into the node modules folder, into FFmpeg static, and call FFmpeg from there, not from my system installation of FFmpeg, because they may have different audio formats. And let's ask for audio formats. Unfortunately, I forget how to do that, so I'll go to the help first and get a way to list audio formats, which they call sample formats. And I will get a list, and it's a short list. Great. And in other cases, like pixel formats and audio filters, there was a list of compatibility, but it seems like in this case there is not. But this list is not right, because it's not listing U-law, mu-law, and these kinds of things. A-law and mu-law and these kinds of things. So this list is not the one I want. This was the one I used, right? Sample formats, yeah. So probably this is the internal representation of the sample in FFmpeg. Probably what I want is codecs instead. Or available formats. Got it, yeah, that's what we want. So I'm gonna run the command again, but this time I'm going to put the output at formats text. And these are not only formats for audio, they are also formats for video. And I want things that have raw audio. So I only want the PCM stuff. I think that everything else is video or subtitles or other things that FFmpeg can work with. I think that the only thing that has to do with audio will have PCM in the name. So what I'm gonna do is select this, Command Shift and L to select all the lines that contain PCM, go to the beginning of the line with Command left arrow, hold Shift, go to the end of the line with Command right arrow, Command X to cut, then Command A to select everything, backspace to delete everything, and paste. And now we have only lines that refer to PCM. This D represents decoding and the E represents encoding. We don't want to use this format because you cannot encode using this format. And most of these things are uneventful, but it's just like different endianness and lengths of things. So it's mostly like linear PCM, all of these options, U-law, A-law. There's some floating point stuff. And there is this one that I have never heard of, but I will take it. So whatever. Let's just put this here. And I think I'm gonna change the default audio filter that we use in these tests is A-Tempo, which is a great audio filter. I think I'm gonna go with Tremolo though. And now to run this thing, I think that this is the command I want. And since I need this command relatively regularly, I will have this, and I will call this something like run. I don't know what to call this. Run? It's a bad name. I'll call this explore, because we are sort of explore. I don't know what to call this. I will call this explore for the time being. Then I can use this by saying npm run explore audio formats. Too many arguments, expected one but got two. Too many arguments, expected one but got two. Why do you say that? The arguments I pass here should be copy and pasted there. Are you really saying that you require me to put this argument before? So hang on. If I get the same error from doing this, I will be surprised. I did not get an error, but I also don't think that the command worked. Yeah, it didn't. It just falls on its face. And what happens if I put this argument before, like this? Same story? Okay, at least that much makes sense. Using Commander, which is the tool we are using to parse command line arguments, it should not matter where we put the named arguments, where the positional arguments matter, like the input is a positional argument, so that matters. But the named arguments should not matter. But why is this not even working? If I run npm start, what happens? Okay, at least that much is working. Let's look at some data bands. Ooh, I became the Hulk. I love these half-tone things. I I have no idea why this is doing this, but it looks amazing. All right, what the hell is going wrong here? Am I being stupid? Probably. npm run prepare, that much is the same, and then node build index examples video short, and that's that. Why is this not working? If I say that I want 2 bands, for instance, I should get a folder with 2 mp4 files, and I do. And then if I say audio formats, it just finishes. I don't know exactly what's going wrong. We are going to start console logging here, which is the last resort. Yeah, same story. We could use a debugger at this point, but who has time for setting up a debugger? I'll just console log. Did I get here? I did not. That's interesting. Ooh, I forgot to declare that this was a valid band type. Ooh, this did not work well over here. Okay, we found the problem. We found the problem. Now that we found the problem and that we fixed the problem, is there a way for us to prevent the problem from occurring again? What happens if I number the number 42? We get a number. If I number the string 42, we get a number. What if I do it to the string Leandro? We get not a number. Okay, so what I should do is how do I represent not a number? Is it like this? Is a property of the global object. Oh, is not a number? Okay. Of course, I only want this if it's not a number. Or actually, here's how this goes. If I have these options, then pass that along. Otherwise, if you give me some bands that are a string and it is not a number, then I would like you to throw a new error that is invalid bands. Otherwise, if it is a number, then convert it to a number, blah, blah. This may not be the best way to represent this idea, but it is one way of representing this idea. If it is on the allow list, allow it. If it is a string, but it doesn't convert to a number correctly, throw an error. And I'm using the trick of using a immediately invoked function expression, because throw is not an expression, it's a statement, but in this position, we expect an expression. I might as well just say for reasons. And then if it is a string, turn that into a number, otherwise undefined. All good. So now, if I npm run explore banana, I will get that error saying invalid blah blah blah. And see, I got the error. No, I did not. Fuck this shit. Why are you doing this to me? We are going to use some more console logs. What happens when I convert that? I should get not a number, and I do. And this, therefore, should be true. And it is. Any guesses? Now, surely this will be true, right? Expect to see 2 trues in a row. And I do. Now I'm going to test my understanding of the AND operator. Now I expect to see 1 true. Why is this not throwing then? Or maybe it is throwing, but we are getting here and this console error is not working as it should. Let's try a console log of error, or maybe of hello, just in case error is something weird. We don't get there. Why don't we get there? Do we get here? We don't get here. What? Just to be sure, Benz is banana at this point. It is. So Benz is equal to pixel formats? No. Is it equal to audio formats? No. Is it equal to filters? No. So this doesn't run. Otherwise, is bands a type of string? Yes. And is this not a number? Yes. We have logged that and we got true. True, false? Hang on, what? What is false? Is this part false? No, that part is true. So is the whole thing true? False. Is the thing on the right false? Oh, it is false now. Oh, the issue was this notch all along. There you go. Now that's more like it. I don't think I like the whole error trace. I think I'm just gonna go with the message. Error is of type unknown. Yeah, whatever. There you go. You noticed this and you were screaming at your screen. I am sure. Yeah, the stream is okay. Only the keyboard is a bit loud here. Fair enough. I am typing angrily because I was running into errors, so I was typing in anger. And I guess it is a bit loud. And I am considering taking with me an external keyboard, not just because of this problem, but also because I think I would like to have the laptop a bit further up, so maybe I can do like a pile of books, put the laptop on top, and then use a separate keyboard, but less luggage the better, I think. So we fixed the error, which was just stupidity. But in my defense, this is a double negative situation. Because we are asking if the thing is not a number. Double negative situations always trip people up. So it's not like I'm alone in being dumb. We want audio formats finally. And I will clean the 16 runs that I had to 17 runs. The cool thing is that all of these things that I delete end up in the trash. These files tend to be big. I'm having to clean up the trash frequently using from working on this project. All right, we're finally gonna see what all the different audio formats look like. I don't expect anything major. I don't expect huge surprises here. I think it's gonna be relatively boring, this one. But I always predict the wrong thing. So I'm not like putting my reputation behind this. The cool thing about data bending is exactly that it is unpredictable. So let's sort this because I forgot to do it before. And let's borrow the header from the one above. And these are audio formats. And then I also want to sort the list here. Wait, it is already sorted? Cool. FFmpeg already gave me the list sorted. So it's nice that all of them succeeded. Now let's look at them. Again, as a reminder, this is what the original looks like. And this is the tremolo effect using a law. Oh, they are different. And they are all interesting. They are both interesting. That's pretty similar. That's similar as well. Not terribly surprising, because these are all floating points. Big endian, little endian, different sizes, but they're all floating points, so I would expect them to look similar, and that's what I was talking about. I don't expect major changes. The A law, let's remember how the A law looked. I think that the mu law is going to look similar. Oh, it does not look exactly similar. A law is more interesting, for tremolo at least. SH looks nice. It adds a bit of saturation to the skin tones. And the tremolo is doing its thing as well with the stripes. Again, we are in the linear PCM territory, so these were floating points and these are signed integers, but they're still like linear PCM, so it doesn't surprise me that they look alike. Wow, we only changed the size from this signed integer 16 bits big endian to 24, and the result is very different. Wow, and in this case we changed the endianness of the bytes, and look at this, not half bad. This is similar to some of the ones above. Similar as well. So one thing we could do is identify the groups that are similar and weight the possibilities differently. So the way that we have here, we have sort of like 5 or 6 that look similar, so they will have a higher probability of occurring, and the result has a higher probability of looking like this. But to be honest, this is true of tremolo. Who knows if this is going to be true of the other audio effects? And in the end of the day, I don't really care that much, because we are going to be randomizing so many parameters that you are not bound to find the same band twice. This one looks kind of cool because it is gentle, but it's doing something. Okay. I am very surprised that just changing from unsigned 16 bits to unsigned 24 bits, we get this behavior. And from changing the endianness, we also get this behavior. Nice, on this one the background is moving. Like an OTV that is... This is an old analog TV that is almost picking up the signal. What? I will take it. I love it. And now you can have access to this too. It's in the GitHub repository that is linked in the description. Typing in Anger could be a nice album title for metal. Especially people who are into metal as well as into type theory. Because then you're typing your types in anger. Get out of here. Don't backspace in anger. An album for bad typists. Don't type in anger by the bad typists. Yeah, nice results. I like them as well. I am positively surprised by the variety. I wasn't expecting that, as I mentioned many times. Anyway, it's time for me to thank you all very much for being here with me. It's great that we can do this even if the conditions are not ideal. So thank you, John, Bo, Mage, Tail, and Anonymous, and Not Was One. Thank you all for joining me here on the chat. It is always great to be with you all and write code together. It is always a lot of fun. I'm not sure when the next stream is going to be precisely, because as I said, I'm going to another place. Who knows how it's going to be there and how long I will take to settle. but it will be this week. I hope I will be able to stream this week. So thank you all for joining me. Make sure you go to the link in the description and try this with your own footage. I think you will have a lot of fun with this. When you're taking a break from playing with ChatGPT, you can play with the data bending stuff. Yeah, Happy New Year, everyone. I'm signing off now. See you later this week. Thanks for joining me. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll be back together for some more coding or talking or chilling. The next time I'll be streaming.